Okay, let's do one more example about the unit step function. Example, it is an initial value problem again, second order. Y double prime plus 3y prime plus 2y is equal to 0. No, not 0, is equal to a function r of t. So whereas r of t is something like this. So this is r, and then this is t. From 0 to 1, it's 0. And then from 1 to 2, it is 1. And then from 2 to above, it is again 0. So it is just this kind of function. So we can say that r of t is 0 from 0 to t 1, and then 1 to t 2, and then 0 for t is greater than 2. So this function can be represented in the unit step format as this, because it has two intervals. So ut minus 1 minus ut minus 2. So you can see that if t is less than 1, so it is 0, this is 0, so it is 0. If t is between 1 and 2, this is 1, this is 0, so 1 minus 0 is 1. And if t is greater than 2, both are 1. 1 minus 1 is 0, so it is 1. Anyway, so we have just checked it. So for solving this initial value problem, in this initial value problem, y0 is 0, y prime of 0 is also 0. So for solving this initial value problem, we need to take the Laplace transform. So the Laplace transform of this r function will be, because these are two unit step functions, for the unit step function we know that the Laplace transform is Laplace transform of a unit step function t minus a is equal to e power minus as over s. E power minus as over s. So in this case, its Laplace transform will be e power minus s, e power minus s over s, because a is 1, and for this a is 2, so e power minus 2s over s. Okay, and now we can take the Laplace transform of this equation left hand side. So we know that the Laplace transform for the second derivative is equal to s square y, capital Y, which is the Laplace of y, s square y minus s times y0 minus y prime 0, and then plus 3 times, for y prime it is s y minus y of 0, and then plus 2y, it is 2 capital Y, and here Laplace of that r function, Laplace of that r function, which I have already determined over here. So in this case, this is 0 because both of these initial values are 0. So 0, this is 0, this is 0. So what we left is s square y plus 3 sy minus plus 2y is equal to this term on the left hand side. Okay, Laplace of r. So what we have over here is s square plus 3s plus 2 into y, then Laplace of r. Okay, and then this is s plus 2 and s plus 1. If you factorize it, so you can write it like this: s plus 2 and s plus 1. And on the left hand side, now I can put these values: e power minus s over s minus e power minus 2s over s. So in this case, y is equal to, now I take it on the other side, so it will be 1 over s into s plus 1 into s plus 2, and then in the numerator we have e power minus s minus e power minus 2s. Okay, so this term, this can be, we can find the partial fractions for finding the inverse transform. So 1 over s times s plus 1 into s plus 2. So for finding the partial fraction, we can use this type of methodology. So we assume it to be equal to a over s plus b over s plus 1 and c over s plus 2. And then we find out these values a plus b, b and c. So for finding the values a, b and c, so we multiplied this equation by this denominator, full denominator. So it will be 1 is equal to a into s plus 1, s plus 2 plus b into s into s plus 2 and plus c into s plus 1. So if we take s is equal to minus 1, then it will be 1, a will vanish and c will vanish, so it will be b into minus 1 and it is 1. So b will be equal to minus 1. If we take s is equal to minus 2, so 1. So this a term will vanish, b term will vanish, so c will be minus 2 and then it is minus 1. So c will be minus 1 by 2. And if we take s is equal to 0, then 1 is equal to, so this term will be a into 1 into 2 and b and c will vanish, so a will be equal to plus 1 by 2. So the partial fractions will be in terms of this. So therefore what we can write is y is equal to a, which is 1 by 2 over s, okay, and plus b is minus 1, so b is minus 1, so b is minus 1 over s plus 1, and c is minus 1 by 2, so c is minus 1 by 2. Minus 1 by 2 over s plus 2. Okay, and then that is being multiplied by this e power minus s in minus e power minus 2s. Okay, so now we are ready to take the inverse Laplace transform of this, but let me write it like in this more in detailed form so that it will be clear. Okay, so we can write it like this. Okay? So we multiply 1 by 1 with these two terms, then it will be 1 by 2 s plus 2 e power minus s, and then plus 1 by 2 s plus 2 e power minus 2s. So we can write it like this, okay, by just multiplying it. So now what we have to do is we have to apply the inverse Laplace transform formulas. So just for as I recall that f of t minus a into u of t minus a, okay, is equal to e power minus as into fs. Okay, that means if we have a function in terms of fs, then its Laplace transform will be this. So here in this case, for if we take we just examine term by term. So in this first term, it is Laplace fs function is 1 over s. So Laplace inverse of 1 over s, we know that it is 1. Okay, or Laplace of 1 is 1 over s. Okay, so therefore this value will be in this case f of s we have identified as 1 over s. Okay, so its Laplace will be this term function f t minus a. So 1 by 2 is here as a coefficient, so we don't do anything with that. So y of t in this case it will be 1 over 2, and then for 1 over s it is actually 1, so 1, okay, yeah, 1, and then for because it is multiplied by e power minus as, a is equal to 1, so ft minus a is actually 1, okay, and that ut minus a will be ut minus 1, so ut minus 1 into 1 is ut minus 1. Similarly for this it will be minus 1 by 2, because it is same as 1 over s, only difference is that e power minus 2s, so it will be ut minus 2, ut minus 2. And for this, what is f of s? F of s is 1 over s plus 1, so the Laplace inverse of 1 over s plus 1, we know that it is e power minus t, right? So it is e power minus t, but according to this formula it should be t minus a, so a is minus 1, a is 1, so it should be t will be replaced by t minus 1, okay, it's like that, and then times ut minus a, so ut minus 1. For this term it is plus e power minus t minus 2, sorry, t minus 1, t minus 1, no, it should be t minus 2, because this t minus 1 will come from, it should be t minus a, okay, it will come from here, minus t minus 2, okay, u t minus 2, okay, so it's like that. Then for this it will be here it is 1 by 2, so it is minus 1 by 2, and for s plus 2 it will be e power minus 2t, okay, e power minus 2t, and t will be replaced by minus 1, okay, and then it will be ut minus 1 for here, and then plus 1 by 2, so it will be e power minus 2t, but t will be replaced by t minus 2, and then it will be ut minus 2. So this long expression will be the answer, okay. We can just write this function in the more conventional way by considering these terms over here, but I can show it to you in the next video clip, which will be shorter because only we have to write the answer in the conventional form. Okay, see you in the next video clip.